Hello, this is Brock Lemires, and in this video we are going to be going over data types and standard input-output. So, up until, or the goal of this recitation activity is to understand the general concept of what we call a data type. And we want to gain a little experience by coding that up in C with the most basic data type. So we're going to look at integers, real numbers, and character strings. And then we also want to look at starting to receive data from the keyboard. Okay, so we want to write a program that will say enter your name and have somebody type their name at the keyboard, and then have us use that information within our program. And in order to do that, we actually have to look at some conversion functions. Okay, so what is a data type? You're going to hear the term data type or type over and over throughout your programming career. And to understand what it is takes time, but at the very introductory level, think about a computer. It stores and manipulates data as ones and zeros. Okay, we always hear that. It's just binary, it's ones and zeros, it's all it knows what to deal with. Okay, and it's true. We don't even know what a 1 and 0 is in terms of hardware, but we do know that ones and zeros are the language of a computer. But how do we tell the computer what the ones and zeros mean? If all it can do is store ones and zeros and process ones and zeros, it needs to be able to know what these ones and zeros mean. So for example, if you just took this code, this binary code, 10101001, what is it? Okay, what does this number mean? Well, it depends how you interpret the ones and zeros. For example, if you decided that this code would represent an unsigned decimal number, it could have a value of 169 in decimal. Okay? If you interpreted it differently, the same exact binary code, you could say, well, what if I treated it as a signed decimal number? Then it would be negative 87. Okay? And then if you said, well, no, I'm going to treat this code as a character, then it perhaps could be the symbol for the copyright. And it's the exact same binary code. So we need to be able to tell the computer what these ones and zeros are and how to interpret it. And that is what a data type is. Okay, so whenever we create some storage or some variable, we have to tell the computer that it is of a certain type. It's going to represent a signed integer, or it's going to represent a character. And it's also very important because it defines how you operate on these particular pieces of information. Okay, so if you're adding characters together, that might not make sense. So you might need, when you do an addition, you might need to know that the input arguments are of type integer. Okay. So let's look at the word variable. Okay, you're going to hear this a lot too when you program in a language. A variable is a location in memory that we can reserve for our program. Okay, so when you have a program, you're going to have temporary storage. You're going to create variables to store information. You're going to create variables to basically store information. You're going to be reading and writing to these locations in memory. But that's the term variable is what we use to describe that location in memory. When we define it, we give it a name in our program, but then we also give it a type. Okay, so you have to tell it not just that you want to reserve some memory, but that you would also like to have that memory store the ones and zeros and interpret those ones and zeros of a particular type. Okay, so let's take an example of the first data type we'll look at. Okay, the most common thing you'll see, and that's called int. Okay, now the int is the keyword in C, and it means a signed integer. Okay, now how many ones and zeros will an integer reserve when you define a variable of type int? Well, it actually depends on your computer. Okay, so if you have a 32-bit processor, okay, you have a 32-bit laptop, that means that it's going to reserve 32 bits of information to store a type int. Okay, now 32 bits, that's not a ton of ones and zeros, but that is able to store down to like 2 billion, negative 2 billion up to positive 2 billion, so it can store quite a bit of numbers. And if you have a 64-bit machine, it will reserve 64 bits of memory, and that's enough to store down to negative 9 quintillion and up to positive 9 quintillion. So it's just massive. It's more numbers than you'd ever need. Okay, so how do we do this? Well, one way we can do it is you just simply put in your main routine or main function, you're just going to say int, and then after it you list the name that you're going to use, and then you put a semicolon. That will reserve, this little code right here will reserve memory and name it A so that you can access it. You can also initialize it if you want to, so you can initialize it on the same line that you actually created it as, or you can do it later. You could come down here and say B is equal to 7. Okay. Now, you can also use integers when you do a printf statement. So this is where the power of printf really comes out, because you're able to actually see what's in your variables. And the way that you do it is you put printf, and then within the parentheses, okay, so within these parentheses within the printf, wherever you want to insert the value of the integer of your variable, you put a %d, and that means decimal. And what it's going to do is it's going to print out whatever is in that variable, in that location of memory, and it's going to print it as a decimal. Okay, and so then what you do is outside of the commas, okay, or excuse me, the double quotes, you're going to list comma delimited the actual variable name. So in this example, what I did is I said A is equal to %d. Okay, it's going to type the characters A, the characters equal, and then the value of whatever A was in decimal. And I can actually have multiple variables in one printf statement. So I can have B is equal to %d, and the way that C knows how to print these in the right location is it's the order. Okay, so the first time it sees %d, it'll put whatever the variable is first. The second one will be second. Okay, so let's get to a little stick time on this. Why don't we fire up PuTTY and let's see how we can do this. So here's my PuTTY again, and what I'm going to do is I saved my SSH login, or the server name, so I'm going to go ahead and say load, and then I'll put open. All right, here's my terminal. Here's my SSH terminal, and I'm going to log into the EELE's 101 server, and here I am. So first thing I'm going to do is I'll say, who am I? Lemires. All right, that's great. I'm warming my fingers up. Let's do a present working directory. I'm in my home directory, and let's do an ls, and I see rec1. Now, I don't like ls, so I'm going to go ll, get a little bit more information on it. So I see rec1. Okay, that's fantastic. Let's remind ourselves a little bit. I want to make a new folder, a new directory, to hold my Recitation 2 activities. So I'm going to do mkdir for make directory, and I'm going to call it rec2. I hit that, and if I do an ll, voila, I got another directory. So I'm feeling so good about myself. I need to get into the rec2 directory. So I'm going to go cd and then rec2. And now, how do I know where I am? I do present working directory. I'm in my home, Lemires, rec2. And let's see what's in here. Nothing. Exactly. As you would expect. Okay, so now I'm going to fire up a little bit of Emacs so that I can start typing. And I'm going to go ahead and just name this file what you will have for the file that you turn in. So I'm going to say Emacs, and I'm going to say rca2.c, and that's going to stand for Recitation Activity 2, and then .c means it's a C program. So when I do that, here comes Emacs, okay? And what I can do is let's type something, and then let's save this up and make sure we're in. So I'm going to go include, and I'm going to go standard.io.h. So I've included the standard IO library, and now I'm going to save this just to make sure that I have a file. So I'm going to go Control X, Control S. I notice that it says save right here. It wrote it, and now I should have this file. Well, how am I going to check if I have that file? Well, remember, you can start up another PuTTY session and get another SSH shell. So I'm going to go ahead and do that. I'll bring over this fella. I'm going to load in my session. I'm going to go ahead and say open. All right. So I log in as Lemires. I go ahead and give the password. Lets me in. I go LL. I see rec2. I CD into rec2. LL. Voila. I have rca2.c. Okay, so I'll put that little fella right there. I'll go back into here. All right, let's begin typing our program. We always do the same thing. We don't even know what this means yet. We go int and main. You're like, hey, we just learned what int was. It's like, you don't even worry about that right now. Okay, you don't have to worry about it. And I'm going to go ahead and open up some curly brackets, and I'm feeling real good. Okay, first thing I'm going to do is let's go ahead and declare a variable of type integer. So I'm going to say int a, I'm done. I've just now reserved memory and I've labeled it a. Okay, I've reserved 64 bits. My computer's 64 bits. Actually, the server, I'm assuming, is 64 bits. I actually don't even know, but it don't matter. Int b, and let's give this guy a value. Okay, so I've got int a and int b, and there it is. And I actually gave them values. So let's go ahead and print these puppies out. So print f, and I'm going to say, double quotes, a is equal to, let's do like is equal to, and I'm going to do our key expression %d. That's going to print it in decimal. Okay, and then I'm going to go b is equal to %d, and that'll be the second expression, and then I'll go ahead and put our new line return, and I do a double quotes. So now I have to assign a and b to that in order to complete the printf statement. I'm all done. I put this return 0. Don't even know what it is yet, but I just type it in there, and now I'm going to do a control X, control S. I wrote it, and now let's go over here and let's remember how we compile. I type make RCA2, no extension. I hit enter. Bada. Got it. LL to see what happened. Oh baby, I got a green RCA2. That means I can execute that executable. I say dot / RCA2. Boom. Now, look at what happened here. This is interesting. A is equal to 0 and B is equal to 7. Now 7 we know was in B, but I actually had no idea what was going to be in A. You never leave a variable uninitialized, so it just randomly was A. Later it might be negative a million. I never know what's in it unless I actually put something in there. But I did do something pretty cool. I have declared two variables of type int, and I have used a printf statement to print them. All right, well that's pretty amazing. Let's take a look at another data type, another common one. Float and double. So you know that if you deal with numbers, you're going to be dealing with real numbers. Okay, a real number is something that can have a fraction in it. So like 3.1415, that's not an integer. Okay, integers are whole numbers. Well, C provides two data types in order to handle real numbers. The first one is called a float, and that's the keyword float, and it's a 32-bit real number. Okay, a double is a 64-bit real number. Okay. And these can take on just massive ranges of numbers. You know, a double can take down to negative 1.7 e to the, that's a 308 right there. Okay, so it's just massive. And all you do is you type it in as you would suspect. Just like we did the int, you just type float, and then you give it the variable name, and then you can initialize it on the same line if you want. Same thing with double. Okay, all right, so we can do that, but you know what we really want to do is look at the printf. How do you do a printf with floats and doubles? You use %f. Okay, so %f is what you need, and it stands for float, and it's actually going to print out the value that you have. Okay, so let's do this. Let's go ahead and bring up our Emacs window, and I'm going to come back up here, and let's give ourselves a little float. Float. C is equal to, let's just do a 3.14, and then let's do a double. And D is equal to, let's make it like something crazy, like negative 22.222, whatever. Okay, semicolon back there. Let's come back down here, and now let's print it. So I'm going to go print F, and I'm going to say, let's see, what should I say here? Let's do C is equal to, and then I'm going to go %f, and that's where I'm going to insert my variable, and that'll do a line return. Okay, now of course I forgot my double quotes, but I caught it. And now I'm going to go comma, and now I put the variable name that I want to print right here where the %f is. Okay, so I go ahead and say C. Okay, and that should work. So let's go Control X, Control S. All right, now I'm going to give you a little hint. Here I am giving you a hint. In the SSH terminal, instead of typing like make every time, you can click the up arrow and it'll walk through the history of your prior commands. So this is extremely helpful when you are continually compiling and running. You don't have to type it in each time. Okay, so let's bring up our terminal. So there's our Emacs, and here's this. So watch this. I'm going to hit up arrow. Oh yeah, it sees my executable, and then if I go up, it sees make RCA2. I go enter. Boom, it just compiled it. Now I'm going to go execute, and look at this. C is now equal to 3.140000. Okay, so it's got a whole bunch of zeros on there. And it's because it's a huge number, right? So it prints out a whole bunch of zeros. Well, what if we wanted to limit how many zeros it had? I can do that as follows. I can go printf, and let's print d out this time. So I'm going to say d is equal to, and then I'll go percent float, and you use percent float for both doubles and floats. But I want to limit it, okay? So the way that I limited it is between the percent and the F, I actually put the number of leading digits, and then I go dot, and then I go the number of trailing digits. So the leading ones are never really interesting. I'm just going to leave it at 2 because I know there's 2. And then I'm going to go dot 3. But that's going to cap the number of these trailing 2s that I'm actually going to see in the print statement. They're still there. They're still in memory, but I'm not going to actually print them. So I go ahead and do a return, and then I list the variable, comma, D, and boom. All right, so Control X, Control S, and now let's go see if we can compile this baby. Make, run. Okay, here we are. Look at what happened. D is equal to negative 22.2222. Okay, so it only had 3 2's behind the decimal point. And that's just a way of printing it out, printing the format. Okay. Life is so good. I'm feeling good. I'm printing all this sort of stuff. Let's look at another one. Char. Okay, now this is the syntax for a variable of type character. Okay, character, char. All right, and what this means is that it's an alphanumeric symbol. You're like, what does that mean? Well, it's all based on this table that was created in the 1960s, and it's called the ASCII table, and it stands for American Standard for Information Interchange. And what they did is they took all the symbols in the English language, and they assigned them a 7-bit code, okay? And this was a good thing because it allowed the computers to store information, and then when it was retrieved, you knew what the symbol you were trying to get was, so that like the monitor would actually print out the right symbol. And so they put all these in here, and then this code, this table, ASCII code, has been extended many times. It went to an 8-bit code to get to 255 symbols, and then today we actually have a thing called Unicode, and that is every character in every language, every symbol you've ever seen in the world. There's like over 100,000 characters, and it just takes more memory or more bytes, more bits in the memory. Okay. Well, what do we care about? We care about char. Chars are going to be 8-bit memory reservations, okay? And all you do is you say char, but when you give it a single character, you put single quotes around it, okay? So like I have E is equal to tick Z tick, and that's how I actually assign that information. The single quotes tell C that this is an ASCII symbol. And when we use printf, what we do is you can guess it's going to be %C. Now that's going to be how you actually do it. Okay, well, let's try it. So I come back over here, and let's come up here. Let's create ourselves a new variable called char, and we'll call it E, and let's make it capital Z. Capital Z is different from lowercase z, some 8-bit code, and I don't even care what it is, because C takes care of figuring it out, okay? All right, so I'm going to say printf, and I'm going to go E, double quotes, E is equal to, and I'll slap down a %C for character, and that's where I will insert the value of the variable E. Okay, all right, well, there you have it. Let's see if that worked. Control X, Control S to save it. I come over to this little fella, up arrow to make, up arrow to run, and bam, look at that. E is equal to Z. I printed a character. All right, I'm feeling so good that I got to think about something. You know what? Characters rarely live on their own. They almost always live within a sentence or phrase, okay? So we have to introduce the concept of what a string is, okay? So the keyword string, it's actually not even a keyword. It refers to a group of characters, okay? And the way that you group together a bunch of individual elements in C is with what we call an array or a vector. Okay, so a string is actually considered a vector of characters. All right, and you're like, what in the world is that? Well, a vector, it's a one-dimensional array. So you can imagine that each element within the array holds a character code, and there's just a whole bunch of them. Now, when you create it, what you have to do is you have to say, I'm going to give this vector a name, and I'm going to give it a type, but I'm also going to give it a size, okay? So let's take a look graphically of how this would work. Imagine that you're in memory, and you're going to, you're going to store hello world. Okay, and I'm just going to write the actual ASCII text. Actually, somebody else wrote it, Dr. Ross Snyder. And this would be what it looks like. Notice that the space bar, actually does take room in memory because it is a symbol. Well, what I'm going to do here is I'm going to have a name that represents where the beginning of the string is. Okay, and then the string is going to have all the characters in it. But C requires, it knows that you're going to have an end of this sometime, and so especially when you use it with printf, it always inserts automatically for you when you create one of these strings this null character. And all null is, the symbol for it is /0, but it's called the null character, and it just means that when C goes to print something, it knows to stop when it sees the null character. It's not going to print like everything in memory, it stops there. Okay, so let's think about this. If I'm going to create a char, or a string, excuse me, I'm going to give it a name str1. Okay, the type of it is still char, so each element within the string is still of type char, but it has a size to it. So the way that you tell it that this is going to be a one-dimensional array or a vector is by putting these square brackets and then inside of them telling it how big it is. So I said I need 12 chars in memory. And you're like, 12? Where does that come from? Well, HELLO is 1, 2, 3, 4, 5, and then the space is 6, and then 7, 8, 9, 10, 11, and then the null. Okay? So the null, you needed that null for the last one. Alright, so I give it, and I can initialize that with hello world, and if I go access this variable name that's called str1, it will go grab this string, and you can print it. C also allows you to, when you initialize it, when you declare the variable, you can also leave the little size blank and it'll automatically determine it, so it'll actually create the exact same thing and you don't have to do the counting. So it's like, okay, whatever. Well, how do you use it with printf? As you can imagine, you are going to have this little special code called %s, meaning string. Okay? Alright, so this feels pretty good. And I can just say printf and life is good. Okay. So let's do it. Let's bring up Emacs, and I'm going to come back up here and we'll start creating some string variables. So I'm going to call it str1, and I'm going to come back and say char str1, give it a size, and let's go ahead and say 12 and then go equals. The way you give it a string is double quotes. So I'm going to say hello world, and I go boom. And I come down here and I'm going to say, alright, printf, and I'm going to say, actually all I really need to do, actually let's do it like this, str1 is equal, and then I'm going to insert %s for string. I'll go ahead and slap actually I don't need to put a new line in there. Yeah, I do. I'm going to put that new line in there, close it up, put the variable as str1, boom. Okay, Control X, Control S, and then I bring up my SSH terminal, up arrow to make, up arrow to execute, and boom! String1 is equal to hello world. I have now created a data type called a variable called str1. It's holding a 12 byte, which is byte is 8 bits. But it's more important that you don't even care about that. It's 12 locations in memory, each holding the character code. Okay, so what else can we do? There's actually some operations which are kind of handy that exist in this library called string.h. And the first one is called string copy. So it's strcpy, and it allows you to basically copy a string from one variable to another. Alright, so for example, let's say that I had my hello world string 1 and I created another string, and I'm using it to make my strings really big so I don't care, so I don't run out of size. So let's say I made a string 2 which was 100 size, so it had 100 elements. All I need to do to copy string 1 to string 2 is I put the string 1 where the source is, and I put string 2 where the destination is, and I got it. Okay, so let's look at how that might look. Okay, so I bring up Emacs, and let's make sure we have a char or a string 2. So I'm going to say char string 2, and this puppy's going to be big. Okay, so I'm going to make 100 elements so I don't run out of room, and I'm not going to initialize it. So it's now empty. I have no idea what's in it. I need to include my new library called include, and this is going to be called string.h. Now I get access to this really cool function. So I'm going to come down here a little bit, and let's see here, make sure you can see everything. I'm going to come down here, and there we go. And right here, I'm going to do a string copy. Okay, so I'm going to say strcpy, and I'm going to copy into string 2, which was empty, string 1. And now I want to see what went into string 2. So I do a printf, and I'm going to say string 2 is equal to, and then I do %s, and I go ahead and do it in new line, double quote, and then I'm going to put string 2. Okay, so now this should be the same as string 1. So let's go ahead and Control X, Control S. That saved it. Then I come over here and I go up arrow, make it, up arrow, execute it. Look at this. String 1 is hello world, was copied to string 2. Boom, life is good. All right. You know what else you can do? You can do a concatenation operator. Now this becomes really handy when you're bringing in information from the keyboard. It's called string cat, and what it does is it concatenates a string with another string. So if I have this string that says hello world, I could add something to it. Okay, so I could add actually something to it. So let's do that. Okay, let's do the following. I'm going to make, let's see what I'm going to do here. Let's add something to string 2. Okay, so let's go string cat, and I'm going to add to string 2, and I could add another string to it. If I did string 1, it would say hello world, but I can also do, let's go like my name is Brock. Okay, and there you have it. So I now concatenated these. So now string 2 has essentially changed values. Now how do I know? Well, let's printf it. Okay, so now string 2 is equal to the exact same thing we did before, which is %s, new liner, and then string 2. So I'm printing string 2 in both situations. It's just it should have more to it after I concatenated my name is Brock. So I'll go Control X, Control S. Come over here and up arrow to make, up arrow to run. Look at this. Hello world, my name is Brock. Would have been nice if I would have left a space in there, you know, but whatever. Not whatever. I'm fixing it. I'm going to go comma space, Control X, Control S, boom, up arrow, boom, boom, boom. How cool is that? I have now concatenated 2 strings together. And that's kind of interesting because in your assignment you'll be asked to enter your first name, enter your last name, then you're going to print both of them out at one time. So you'll actually be performing a concatenation. Okay. All right. So now what is next? We would like to now look at getting information from the keyboard. Okay? We are now going to take information from the keyboard and bring it into our program as a string. Okay? Now, when you get information from the keyboard, it's called standard input. That's just the name for it, and its abbreviation is stdin. The reason we messed around with strings and characters so long was because every keystroke on a keyboard comes in as an ASCII code. It comes in as an 8-bit character, and it doesn't matter whether it's capital Z, lowercase z, those are 2 different codes, but 1, 2 through 9 also have 8-bit codes, and they're the symbols. It does not come in as an integer 1 when you press 1 on the keyboard. It comes in as the ASCII symbol for 1. Okay, so that's very important because if we want to use information from the keyboard as a number, we're going to have to convert it. Okay, but first let's look at how do you get information from the keyboard. Well, there is a function that is called fgets, and it actually is in the standard io.h library. So it's in the same one as printf, so we don't have to include a library. But all you do is when you execute it, it will stop the program and wait for somebody to type something until they press the enter key. When they press the enter key, the information will go into your program and it comes in as a string. What you need to do is you need to provide a destination, which you have to create a string variable, and then you have to give the size of the variable, and then you have to give the source. And what we do with the source is we enter that keyword stdin, and that means you're reading from the keyboard. Okay, so let's take a look at how this might look. Okay, so I'm going to bring up Emacs. And I now, let's get a new string here. Let's go char string 3. Make it 100 again because it's huge. And then let's come down here, and I want to do this. I'm going to say printf, what is your name? Okay. Line return, boom, boom. And then I'm going to go fgets. And I'm going to say put whatever this person types into string 3. String 3 happens to be 100 long, 100 elements, and take it from standard in. Okay? All right, and I did it. And as soon as I hit enter, that thing's going to go into string 3. Well, we want to know what's in string 3, so let's do printf and then say you, or your name is, and then I'm going to print whatever that string was. Okay? And I'll put a line return in there, and then I'm going to enter my variable as str3. Okay? All right, well, let's see what happens. Control X, Control S. And now I bring up my console, and I say make that puppy, and then run that puppy, and look at what happened. We are sitting here. It's printed all my variables, but look at it. It says, what is your name? And I'm going to say, well, my name's actually Brock. So I type it, hit return, and it says, your name is Brock. So it actually worked. It spit it back to me. Now, here's what's interesting about fgets. When I hit return, it actually takes that in as a character. So it actually has an extra return at the end of the fget string. And it's a pain for right now, but this is pretty introductory stuff, so I don't even want to worry about trying to get rid of that. Just know that when you print this stuff out, whenever you read a string from the keyboard, it's going to have an extra return at the end of it. Okay, and there's a lot of ways to get rid of it. It's not a big deal. We can figure that out later. Okay, some notes. Just what I said. You have a line return at the end of each string when you use fgets. But there's also another cool function that's called size of, and it's way better. It returns the integer value of the size of a string or a vector, and it's a lot nicer to use that in the middle argument of fgets than it is to type in 100. Okay, so it automatically finds it for you. So if I could type the exact same thing in with size of, and everything would be great. Okay, so now here's the biggest trick. You bring in a number. If I'm bringing in like pi or bring in my age, what happens is that it comes in as ASCII characters, and I want to convert it into something that is a number. I want to convert it to an integer or a real. So guess what? C has some built-in conversions. So there's this one, and they're in a library called standard lib, standard library. And the first one we'll look at is called ATOI, and that stands for ASCII, which is the character, to integer. Okay, and all you do is you just put the value in there and it returns an integer. Now that means you have to assign this to a variable, but it's not that tricky to do. So all you do here is you just got to make sure that you have a variable declared that is of type integer, and then you just convert it. Okay, so let's do it. Here's an example. Let's do an integer. So I'm going to come along and I'm going to say I got my name, and let's do this now. Printf, enter a 6-digit integer. Okay, and return. And then I'm going to do fgets, and I'm going to put this in a new one that I'm going to call string 4. So let me pop back up here. I'm going to go char string 4, make it huge, 100, and then 100. And now I got this new vector that I've created, and so I go fgets, and I'm going to say string 4, and then the size of string 4, I'm going to use my new function, size of, and then string 4, and then I'm going to say get it from standard in. Okay, now I'm using size of, and I'm using a conversion that's about to come up. So I need to come up here and I need to go include standard lib. So now that gives me access to these functions. Okay, so I'm feeling good. Okay, I'm feeling good, and I can actually make my window a little bit longer. Okay, so I feel pretty good here. I'm ready. I've got my, holy moly, jumping all over. Printf, I enter a 6-bit integer, and I'm going to get it. The only problem is that it comes in as a character. Okay, so it's a character string. So what I want to do is I want to convert this, but where am I going to put it? I'll tell you what. You know who's an integer? Remember A? Remember this guy A that we had that we didn't initialize? It's empty. Let's go ahead and just slap that in A. So I'm going to say A gets, and I'm going to say ATOI for ASCII to integer. All I do is type string 4, and I've now converted the string, the 6-digit integer string that someone typed, to an integer, put it into A, and now let's see what happened. Let's go printf, and this time I'm going to say your integer is, and I'm going to put %d, and that will verify that it is an integer because I'm printing A now. I'm not printing string 4, I'm printing what I converted it, and it should be operational. So let's Control X, Control S, and now let's bring up our shell, up arrow make, up arrow run. What's your name, Brock? Enter a 6-digit integer. 1, 2, 3, 4, 5, 6. Your integer is 1, 2, 3, 4, 5, 6. Bam! We did it. We converted a string to an integer. This is so fun. I just want to do a little bit more. Okay? Guess what else you can do? You can convert strings to doubles. Okay? We're jumping right over floats. We're going straight to doubles. The function is called ATOF. That stands for ASCII to float. Also in the standard lib library, so we don't even need to mess around with it. Let's go ahead and do the exact same thing. So I'm going to say printf, say enter a real number. And I'll go ahead and go return, line return, and then I'm going to go fgets. Where am I going to put this? You know where I got to put it? I'm going to need another string. Let's go back up here. Memory's just so cheap these days, you just don't even care. You just make another string. String 5, how big? 100. Why not, huh? So then we come back down here. I'm going to do fgets. I'm going to slap this thing into string 5. The size of string 5, I'm going to call a function called size of string 5. And then I'm going to get it from stdin, standard in. All right, I got it. Now I want to put it somewhere. So here's something interesting. We need a double. Okay, we're gonna convert this string to a double. So let's go ahead and see if we got any doubles. Check this out. D is a double. Okay. Now we initialized it, but later in the program we can blow it away. Who cares, right? We're done with that value of it. Let's look at blowing this D away here. So we're gonna go D gets assigned ASCII to float of string 5, and now I converted it and I stuck it in D. So I need to know what's in D now, so I'm going to go printf and then say your real was or is, and I'm going to go boom, %f for float, line return, and now let's print the variable D. All right, Control X, Control S. Let's go ahead and up arrow make, up arrow run. What's your name? Brock. Integer 1, 2, 3, 4, 5, 6. How about a real number? How about 3.1415? Boom, look at this. Integer, it got that. Enter a real number, I got that, and it got it back. So how amazing is this? Okay, so this feels so good, okay? To wrap it up, you can have different types printed within the same printf statement. So check this out. I don't have to always have a single printf statement in order to print just integers or just floats. I can do the whole thing. Printf, check this out. I'm going to say this. Your name is boom. And I'm going to say string. Now, I got to remember something. When I have this string, so I'm going to have a bunch of junk here, and then I'm going to come over here and I'll have my variable. And the string that is storing my name is string 3. But remember that string 3 has a line return at the end of it, because that's just how fgets operates. When you do these functions, these conversions, it'll actually take them out, take the line return out. But this one has it on there. So if I wanted to make this look pretty, I would have to remember that that is there. So I would say your name is something. I know immediately it's going to do a line return. So now I'm going to do your integer is, and I'm going to put parenthesis D. Now I am going to do a line return to make it look good, because this first string already had a line return. My second one, I needed to put it because I'm printing an integer. And now I'll do your, what do you want to call it, float? Or let's go real. Your real is, and then I do %float. And then let's do like a couple line returns. Okay? Lots of them, 3 of them. All right, so string 3, and then who's going to be printed in the decimal? Or the integer? Let's do A. And then what about your float? I think we put that in D. Close it on up. I don't know if it closed. Let me make this window a little bit bigger. Looks pretty good. So Control X, Control S. Let's come over here. Up arrow to make. I got an error. Look at that. Oh, I did print instead of printf. That's no big deal. Printf fixed. Control X, Control S. I come over here. Boom. Make. Run. What is your name? Brock. Enter a 6-digit integer. I'm going to go 654321 this time, mix it up. And then I'm going to go negative 3.1415, no reason. And then, oh, look at what happened. So it says your integer is this, or your name is Brock, your integer is this, your real is this. Then these 3 lines right here, or your name is Brock, your integer is this, and your real is this, these were printed with one printf statement. Okay? Okay, you did it. So now, what's next? First of all, look how happy you made me. I'm smiling so much, it's almost awkward, okay? So this is fantastic. At this point, you're going to go take the Recitation 2 quiz. Then if you were following along, you almost have done the entire program. So you're going to go get the Recitation 2 handout, get the instructions. It's basically enter your first name, enter your last name, enter an integer, enter a real, print it all in one printf statement. So you're going to have to concatenate, but you have to use a concatenate operation. Should be pretty straightforward. Once you do that, go to your recitation, get it demoed, and then upload your code to the Rec2 code upload. And that is it. Good job.